Electronegativity is a very important term in Chapter 4. It is the ability for an atom which is covalently bonded to another atom to attract the bonded electron pair to itself. Similar to ionization energy, electronegativity is influenced by nuclear charge, the distance between electrons, or also known as atomic radius, and the shielding effect of inner shells and subshells. Electronegativity increases across the period as the nuclear charge increases while the atomic radius stays relatively constant, and decreases down the group because the atomic radius and the shielding effect of inner shells and subshells increase. The Pauling scale is what we use to measure the electronegativity of atoms. A higher number represents a higher electronegativity. For example, carbon has an electronegativity of 2.5, while hydrogen has 2.1 and nitrogen has 3.0. Fluorine is the most electronegative atom, with an electronegativity of 4.0. Polarity is another concept that arises due to electronegativity. It is defined by the distribution of electric charge over atoms joined by the bond. The more polar is a molecule, the more unevenly is the electric charge distributed within the molecule. A molecule becomes polar when the two atoms in the bond exert a different amount of attraction on the electrons in the bond. This results in the electrons being closer to one of the atoms, making the charge distribution uneven. In a polar molecule, the center of the positive charge is different to the center of the negative charge. The positive center is closer to the less electronegative atom, while the negative charge center is closer to the more electronegative atom. The electron distribution is also asymmetric. Consequently, the two atoms in the bond also become partially charged. A permanent dipole is also formed within the bonds. Intermolecular forces is something that comes up a lot during GCSE, but still, let's recap about this force. By definition, it is the attractive forces that arise between the positive and negative components in a molecule. In general, intermolecular forces are weaker than ionic, covalent, and metallic bonds. The van der Waals forces is the generic term we give to all intermolecular forces. It specifically refers to the intermolecular force between molecular entities other than those due to bond formation. The first type of force we are looking at is the instantaneous dipole to induced dipole force, or in short, the IDID force. As its name suggests, it is a force formed between a temporary dipole and a dipole induced by this dipole. It is the weakest intermolecular force amongst all others, with a strength of only 1 to 20 kilojoules of energy per mole. This force is created during the continuous morph of the charge cloud in the molecules. When there are more charge cloud on one side than the other, the molecule forms a temporary dipole. This dipole induces another dipole in molecules surrounding this molecule, creating a temporary attractive force. This happens all the time in a group of molecules, since the electron cloud is moving continuously. The second type of force is the permanent dipole to permanent dipole force. It is formed between two permanent dipoles, which meant that this force only forms between polar molecules. The force is positively correlated to the polarity of the molecules, with a strength ranging between 5 to 20 kilojoules per mole. Within the PD-PD forces, hydrogen bonding is a special case. It is a force formed between permanent dipoles in molecules where the hydrogen is bonded to a highly electronegative atom. As we have mentioned earlier talking about polarity, the atoms involved in a polar bond becomes partially charged. This may result in the molecule becoming polar. Within the molecule, the positively charged atom is represented with a symbol delta plus, and the negative atom is represented with delta negative. Take hydrochloric acid as an example. The chlorine atom has a higher electronegativity than hydrogen. So hydrogen, having less of the negative charge, is the delta positive atom. Chlorine and complementary is the delta negative atom. However, be careful when determining whether a molecule with multiple atoms is polar or not. Despite the bonds within the molecule being polar, it is still possible for the molecule to be nonpolar considering the polarity of each bond and its arrangement. For example, despite having polar bonds, carbon tetrachloride is still a nonpolar molecule. Let's look at how the electrons are arranged. Since chlorine is more electronegative than carbon, the electron pair in the bond is closer to chlorine. This makes the electric cloud closer to the chlorine atom. But since there are 4 identical electric clouds in 4 directions, the unevenly distributed electric clouds becomes even. This is all for this video. Thank you for watching, and remember to subscribe for more A-level chemistry videos.